Hi, I'm Mark and in this video you are going to learn how you can join data from multiple tables. This is especially useful when you're working with relational databases. So let's begin. So we've got these tables which are about 9, and I'll be working with Lego dataset, which is a popular game where you join the pieces together like in a sort of a puzzle. So this piece they are from 1952 up to today. So each and every year what the company does is there may be new design for the Batman, for the cars, for anything. So you just need to fit the pieces together. So the pieces are stored in multiple tables, and we will be joining them so that we can get more understanding on those pieces, right? In a business scenario, you see that tables, when data is stored in a business, in a database, is stored in a relational tables. So if you want to get full information about the business, you need to join the tables. That's why this topic is very key, and you meet this every day in data science or data analytics or in reconciliation or in any business case or in any field. There's that need for scientists to merge the data. Right, so let's dive right in. So like always, we start with importing our libraries. Then we are going to import the colors dataset. Let's have a look at it. So it has 3 columns. We've got the ID, the name, and RGB, which means the color code. Let's import the next one, the inventories. So you can see here it has got 15,000 rows. It has got 3 columns. You've got the ID, the version, and the set number. Inventory parts, it is 258,000. It has got 4 columns, the ID, inventory ID, the part number, the color ID, as well as quantity. So we look at the part category. It has got 64 columns. It has got the ID and the name. So I think this is a lookup table, right? Okay, let's proceed. Let's look at the parts. It has got 17,510. So we've got the part number, the name, and the part cut ID. The question tags, 497,000. It has got the question ID and the tag ID. The questions, 294,000. It's got the ID, the creation date, and the score. Then you've got the sales table, which has got 4 columns, the set number, the name, the year, and the theme ID. You've got the tags table, which has 2 tables, the ID and the tag name. Look at the themes table. It has got 3 columns, the ID, the name, and the parent ID. Okay, that's your themes. Then you've got the answers table, which has 380,000 rows. It has got ID, creation date, question ID, and the scores. So here's what we're going to do. We have got 9 tables, and this is like the situation that you really meet in real life, right? You've got multiple tables, and for you to get insights, you need to combine these data sets. So let's look at it. In the first case, we want to join the parts and the part categories. So what we need to do is you want to find which category for each part. So if we look at let's look at the tables. I've increased the size of the screen there so that you can see for my global environment. So I'm going to look at the parts. Let's look at the parts table and the part categories. So we see that the parts table has 17,501 rows. Then let's look at the part category. The part category has 64 observations. So when a database is being created, I'm going to do videos on databases. So just hang on. I think in the next month we'll be looking at databases broadly and diving in. But I just want you to know that at this point, when you want to create a good relational database, you want to remove duplicates. You want to have a table where there's atomicity. Okay, don't worry about the big words, but what it simply means is that you don't want to don't repeat yourself, right? So we remove the categories and create a table of categories, right? Because each part can have multiple categories, right? Like each part belongs to a category, but the relationship between parts and categories there is a one to many. It's not a one to one relationship. So we need to pull out these things and create a table for them, right? So what you want to do is you want to join the two tables, right? So what an inner join does in this case is it's going to look where it's going to join the tables wherever there is a match, right? So we are going to have each part allocated a part category. So the way we do that in R is you need a table. You need the first table, then the verb inner join, which does the job. Then after the inner join verb, you then put the table. Then by equals to C. C in R is a special word for combine, or which we use for even creating vectors, right? So we're saying by equals to part cut ID, right, and ID. So if we look at those two tables, we'll then see that we have got this part cut ID in the parts table, and in the part categories we have got the ID. So that's where we can link the two tables, right? So if we run the code here, we are going to have our tables. And before I proceed, I just want to let you know this type of joints are called mutating joints, right? So broadly, we have got two types of joints: the mutating joints and filtering joints. We are going to look at filtering joints later on in the course, but right now we're just focusing on mutating joints. They're called mutating joints because what they do is they create extra columns in the data set, right? So that's it. So when we after sorry for this message that keeps popping up on my screen. So when we create these tables, we see that we now have got more columns, and we had name and name in each of those tables, which is not nice when you're doing your report, because R automatically infers that the first, it doesn't keep duplicates, right? So what it then does, it creates this dot X and dot Y so that the two columns are different, right? So we can actually make this intuitive at one go without having to type each and every time. If we are automating this process, the way we would then do it is we say we add another argument called suffix, which is equals to C. And you remember the C, which I said means combine, and I said it's used when you want to do multiple things, when you have multiple operations. In R you use the combined. I said it's like a vector where you're saying, okay, I'm joining these things, right? Okay. So when I say underscore part and underscore, it means that R is going to say in the first instance on whenever there is like two similar names when the join is being done, the first one add an underscore part and the second one add an underscore category. That's what the code is doing. So I'm saying use the suffix argument to replace .x and .y suffixes, right? So if we run this, we now see that we have a new column name called name part and name category, which clearly then illustrates where there's the source table, right? And if we are working in a collaborated way, it will be very easy for the other person to see what I was doing. So that's the inner join. So here, let's proceed. I'm saying joining with one-to-many relationship, joining parts and inventories. Connect the parts and inventories table by their part number using an inner join. We have covered that. Combine the parts and the parts tables. Okay. So let's look at the two tables. The parts table, we have looked at it. Let's look at the inventory parts, right? So the inventory parts, okay, it's this one, right? So in the inventory parts, we see that we have got 258,000 columns. We've got an inventory ID, then we have a part number, then we have got a color ID and the quantity of those parts. And we want to join this with the parts to say maybe which this part, right, it belongs to which inventory. So if you look at this table, this pass is 17,000 and the inventory parts has got 250,000, 58,000. So we're seeing that this relationship is a one-to-many relationship. So let's do the join, because if you look at the parts, it is 17,000 and this one is 254,000. So we see that when we run this, we first need to find the column that has got a match. In this case, the match is on the part number, and if I go to the parts, I've got a part number, so that's where the match is. So whenever you are joining table, or when you are creating tables in a business case scenario, you need to have like what we call the unique identifiers that you can then use to join your data. So when I run this, we have a table with 258 columns, right? And 958. We see that the new table that was created is exactly as the same number as the parts, the inventory parts, right? Which then makes sense to say at the inventory parts, it has got all the parts, right? And the parts has got all parts, but all the parts are part of inventory, right? So that's the sort of logic that really follows here. Let's see if we've got issues with the column names. No, we don't. So there's no need for you to then use the suffix argument. Then we can also join the inventory parts and inner join, parts by equals to part number. We see that the same number of columns are maintained, right? And combine the inventories table with the sets table, next join. So I think for now I'll leave the code and the data sets on Arastas Zim. You can go there and practice, but for the inner join we have covered the inner join. Maybe what you may want to do is to say, okay, let's say you have got 3 or 4 tables that you want to join using an inner join. It's still the same logic. What you then do is you extend the code, right? And this is very good thing about one good thing about R is that you can just continue to chain methods in one go. There's no need for you to, and the code is very short and R runs fast, as you're going to see. So you want this time you want to join the sets table, which is this table which is got 4,000, right? We're saying the name, the sets, all the sets of the Lego table. Then we will join it. We will join it to the inventories, which we have already seen. Right, so the inventories has got 15,000. So we are saying all the sets join the inventories. Then after that, we are going to join that to the inventory parts, right? So the inventory parts has got all the parts. So we are going, what we will then end up with is we are going to end with a set name, then we are going to end with the part and the inventory parts, which becomes very powerful to see which part belongs to which set and which set has got what parts, right? So that's it. And when we run the code, we now have a very large table with 9 columns, right? We see that we have managed, if this was a report, you have managed to capture the relationship between the tables, and then your analysis becomes very powerful. So we can proceed and do as many joins as you want. And in this case, if you look at the sets joined to the inventories and to the parts, and then we added also the color to see which colors were most dominant, you could then do that sort of an analysis to see which colors people tend to use, the Lego company tend to use most. And maybe if you're working for that company, like, you will be then prepare for the quantities and to just have an idea and focused at things like that, right? So if we run this code, we see that our suffixes work. We now have got a table with the theme ID and color ID added. We also have got the name set and the name color added. And so that's it with the inner join. And remember, if you did not watch my first video, I was explaining about the types of joins that we have and what they tend to do, right? So one other thing that businesses always want to do is to say they want to have data arranged in some way. So using our chain operator, which is the Control Shift M, if you have already forgotten, we can then add a count to say after all the join has been done, I want you to count, which is count is it's group by and summarize, right? So we're then saying I want you to group by the name color and then give me a summary of each color to see how each color was used in the creation or in the Lego data set. So if we run the code, we will see that we end up with the summary statistics, and then we will see that black is the most common color in the Lego data set, followed by white among other colors. So you remember from the video, if you have forgotten about data manipulation and the count and the group by and the summarize, You can then watch my video which I did last, which in data manipulation with R, right? So what also we normally do is sometimes when after you have done your manipulation, you remember you need to store it in a variable. So I'm creating a variable called a table actually called the inventory parts join, which is an inner join of the inventory parts. um, then I'm also selecting some color which does not add much to my analysis, like the ID and the version. Then I'll arrange in descending order by the quantity, and that's how I'm going to create my table, right? So what I then have is this new table which has got 258,000 by 4. It has got the set number, the part number, the color ID, and the quantities, right? So I will be doing joins. So what I want to do now is I want to filter um, a certain uh, set number, which is I want the set number 79651, right? And this was the Millennium Falcon. Then I want to analyze another one, the set number 75190, which is the Star Destroyer. So we are going to look at the relationship between two these two products, the Millennium Falcon and the Star Destroyer. So we want to compare them in terms of the color that's used, we and the quantity that were bought, and maybe if they have got, we want to look at that relationship, right? So we're going to combine the Star Destroyer and the Millennium Falcon tables. So the way that I can do that is I can use a left join. So what the left join does is I'm saying, okay, look at the Millennium Falcon table and join it to whatever that is in the um, Star Destroyer, as long as there is a match, right? So running this code, we then see that everything that was in the Millennium Falcon table is kept, and everything that had a match in the Star Destroyer was imported into the table. So that's why we have got this NA. What this NA means is that we could not find a match in the Star Destroyer. That's why if and when where these columns are complete, it's because that there was a match in the other table. So that's the relationship between the two tables in terms of the sets that are common, that were used in the Star Destroyer and the Millennium Falcon. So those are sort of things that you then need to do in a real use business case scenario, where you're looking at maybe this which customers are bought the same product A and product B. So you can then do a left join if you are interested on one product, and it how it also maybe like the similarities that it has with the other pro. So if we use a left join, that's what we then get. So um, we can proceed. Then the other thing that we can also do is is the group by and the summarize, which so here we are going to do an exercise where we're saying sum the quantity column by color ID in the Millennium Falcon dataset, then aggregate Millennium Falcon for the total quantity in each part. So how can we achieve this? We will then say, okay, in the Millennium Falcon, this is our dataset. So you've got the set number, the part number, the color ID, and the quantity. So we are saying sum the quantity by equals to color in the Millennium Falcon dataset. So that's why I'm saying the Millennium Falcon group by the color. So what will then happen is that my data is then grouped. So let's run this code which I've highlighted. So under the hood, what R has done it is that it is grouped all this the table using the color ID. So after grouping is most useful when you it's combined with the summarize so that you retain. So after that, I'm going to sum the quantity based on the color, and we then see that the color ID 0 had the most quantity um, in the Millennium Falcon dataset. So I'm going to create this new table, which I'll then report to a manager or or my bosses. So after that, the next instruction that's now sum the quantity column by color ID in the star destroyer dataset. Aggregate aggregate star destroyer for the total quantity in each part. Okay, so we're just doing the same to say um, again with the star destroyer. So after those two, we now want to join the two summary tables to make an even more powerful statistic, which will then show us the grouped summaries. So we see that in the color ID, the color ID 0 in the case of total quantity in Falcon was 201. Then in the case of total destroyer, so you can even go further to then subtract the two, and what you can see, guys, is that this becomes a very very powerful analysis for a boss, but you're not going to we had to do this in sub steps in order to achieve this sort of a result, right? So let's proceed. Use a left join to join together sets and inventory using their common column. Okay, so we create the version 1, then says join the two sets. We are going to join the sets and the inventory version 1 by set number. So this is what we then get. Alright, guys, the other join that we have is called the right join. The right join and the left join are the same. It's just that um, it's the operation where it's going to be effected from. If it's a left join, it's going to be effected on the left, and if the right join, the operation will be based on the value on the right. Okay, so I'm not going to spend a lot of time on this one. Sorry. So here we've got the pipe, the parts, and whenever we do a count, it's essentially, like I said, it's a summary and group by, right? So we're saying parts count part cut ID. So we're saying group by um the group by and summarize. Let's see how it looks. Okay, so we see that we have got a grouped summary where we are saying the part cut ID n is equals to 135, which means the number is equals to 135. So what I'm going to do with this is I'm going to write join part categories, right? I'm going to use this table as a lookup table to the part categories. Let's have one more look at the part categories. So this is the part categories, right? It has got 64 entries, right? So let's do the lookup. Okay, So when we do the lookup, we will then have the name um, for each part category and the number. So in this case, you see that the part cat ID, its name is best place. It was just best place, right? Okay, let's proceed. This is the same. So the other thing that the other verb that is also powerful when you're doing using R is the is now, which you can then filter for not uh, missing values, right? So what we will then see is that we went in the data set and picked out the value where there was no any part. So we see that the part cut ID 66 with the name modulex, we don't have any piece there. So this is could be let's see um there's got a library called tidy R, right? Which you can use to clean your account, right? In both the left and right join, there's an opportunity for there to be NA values in the resulting table. In the last exercise, we saw that N had NAs after the right join. So let's use the replace NA to replace what those values with 0. So we import the library tidy then we say parts count the part right join by, then after that we'll then use the verb replace NA list N is equals to 0, right? So when we do this, we are going to find that we don't have um, any value where there's an A, right? So let's proceed. So we also have got an inner join. I think we have covered that. Then this is a bit advanced, but for the sake of time, I think we just have to proceed. We have covered the inner join. We've covered the left join. Then this year, what this is also saying is that we can join a table on its own. There's You can have one table and join a table to itself. It's quite possible, right? So this is what we will cover this in another video. But or you can just go through and read these notes. Okay, guys, I think we'll meet again in the next video where we'll proceed. My time is up. Okay, bye.